Here's a look at Sandy, and here's a look inside Sandy.
We have these satellites that give us CAT scans of hurricanes.
Using radar instead of X-ray. We also have satellites that give us snapshots of hurricanes. And these visualizations of Sandy, mostly coming from NASA and NOAA, help with the storm in perspective. For starters, says research meteorologist Marshall Shepard.
I like to say that size does matter in this regard.
And Sandy?
It was so large.
So large that thanks to the GHOST satellite, you can see it rolling over the globe.
Essentially, every U.S. citizen east of the Mississippi River was experiencing some influence of the storm, whether it be wind, snow, rain, storm surge. That's how large it was.
Compare that to Irene, which seemed like a behemoth at the time.
Some of the other storms that we've seen have been significant, but relatively regional in scale. This thing was affecting the entire eastern United States.
Not just big, Sandy was 2 storms in one. On its way up the coast, the hurricane bumped into another storm. That line of clouds you see indicates the cold front of that other weather system that Sandy merged with.
We knew that it was not going to necessarily weaken the way a hurricane does when it makes landfall, because it was just going to transition from a storm that was getting its energy from the ocean to a storm that was getting its energy from the atmosphere, the so-called extratropical storm or mid-latitude storm or nor'easter. Really interesting because we had this really late season hurricane phasing up, if you will, with this really early season nor'easter.
And then remember that bizarre left turn Sandy took? And that was another weather system at play.
We had a big area of high pressure up to the north that essentially was like a big roadblock, if you will. And that roadblock forced Sandy to make a left turn.
And get this.
That same high pressure system that caused the blocking was also creating quite a bit of warming that perhaps was even related to the extreme melting that we saw over Greenland earlier this summer.
Over 4 days in July, this swath of ice on Greenland melted. Red stands for melt. 4 days. The high-pressure system associated with that melting might have been
the culprit that led to the turn to the left instead of the right.
Double whammy. Now, when you look at this imagery, Sandy seems pretty flat.
The weather of the Earth, if you're looking at a soccer ball, would be confined to a very thin skin.
Or if you're looking at it from the International Space Station, which you are.
So the weather is almost a two-dimensional phenomena.
But almost is the operative word here.
TRMM satellite is the first satellite in space that has a radar that can measure the detailed three-dimensional structure of precipitation. That means rain, snow, ice particles that hide inside of clouds. And the TRMM satellite is one of the best kept secrets of NASA.
Owen Kelly works with data from this satellite at NASA Goddard. And to be clear, the mountainy blob doesn't represent clouds.
It's the rain hiding inside the cloud.
That's important because
it helps us understand the energy transformations going on. When water condenses into raindrops, which we can see with the radar, it releases energy. Gram for gram, every water that condenses is a certain number of joules of energy that are released.
This energy release impacts our experience of the storm.
What affects us on the ground is wind and things falling out of the sky, like raindrops, hail, and lightning. All those things that affect us are driven by the energy transformations.
So you can think of the blobs like
the pistons that drive the hurricane, and with TRMM you can see them.
TRMM looked into the eye of the storm about a day before it made landfall.
And it showed that there was a well-organized ring of clouds, which is called the eye wall. And for a storm this week, and over such cold waters, it was unusual to see an organized eye wall like that.
While these satellites give you a big picture of the storm, how about the even bigger picture?
2 words: climate change.
So what does climate change have to do with Hurricane Sandy?
There were 17,000 news hits for Sandy climate change, according to Google. To make sense of this connection, Marshall Shepard offers this.
The best analogy I can give is that during the Major League Baseball era of the last decade, there was quite a bit of a discussion about steroid use and the fact that we were seeing more home runs in baseball and longer home runs. Well, that was probably related to steroids, although any specific or given home run by any individual batter I couldn't attribute to steroids, although we know that there was a general uptick in the number of her home runs and their distance. And that's how I look at this particular storm. I can't put an exact fingerprint of climate change on this storm, but it certainly is indicative of the fact that we might be seeing a climate system where human-induced climate change is the steroid for these weather systems going forward.
For Science Friday, I'm Flora Lichtman.